Hello all, welcome to the web application pen testing course. Now, we are going to start from the very basics, and I can understand that different viewers at this point would be in different stages of knowing about web application pen testing. So I'd probably request all of you to be a little patient because I think the initial couple of videos for some of you would either be a good recap or for the experts among you could even be trivial, right? So please be patient and we'll get to all the more kind of fun stuff very soon. So having said that, let's start from the absolute basics, right? With what is the HTTP protocol? Now, HTTP stands for Hypertext Transfer Protocol, and really, I mean, very simply put, it's a client server based architecture where you have a web server which is going ahead and serving what we call resources. These could be files or something else. And you have the client, which could be your browser or some other program which you're running. And the client requests resources to the server, and depending on if the server has the resource, the client has authorization, and a bunch of other things which we'll get into later, the server may serve the resource. Now, as you can clearly see, this is a very simple request response mechanism, right? The client requests for a resource and the server serves that resource. Now, the question is, how does one go about naming that resource, right? Uh, so in the world of HTTP, we identify resources with what are called URIs or URLs. So if typically most of you kind of remember, URL is pretty much the thing which we type in into the browser box on the top, such as http google.com or specific links to files, etc. And the browser knows how to reach that specific server and request for the resource. Now, HTTP as it exists today pretty much has two versions, 1.0 and 1.1. 1.1 is really the more prevalent one, or rather should be the more prevalent one. The key difference is that 1.1 can reuse the same connection and request multiple URIs, right? While in the case of 1.0, you would require one connection per resource and disconnect immediately. Now, how does all of this really work? So I've taken up a very simple example in which you have a web server, which of course would have a database server depending on the application logic, and you have a user who, using his browser, goes ahead and makes an HTTP request to the web server, maybe for the home page, a file, a movie, whatever he needs to see. Now, the question really arises, what happens in the background when this process goes on? Now, you know me, I hate slides beyond a point. So let's go ahead and dive into the details. Now, for this specific lab, I'm using Kali Linux as my platform. You could use Backtrack or anything else. The only requirement is that Netcat, curl, and Wireshark be installed, which is installed by default on Kali and Backtrack, and that's really why I'm using it. If any of you guys would like a primer on Kali, Backtrack, or how to install it inside VirtualBox or Bare Metal, use the feedback link which is there as soon as you log in into Pentester Academy, and I'll probably make a video as well, right? So no question is too trivial. Ensure you let me know if you want a video on that. Okay, so we said HTTP requests is pretty much what drives the internet and the file fetching and all of that, right? So now let's look at how an HTTP request looks like at a very low level. So for that, we are going to go ahead and start Wireshark, which is a network sniffer. For students who've never used Wireshark, it basically allows you to analyze network traffic at a per packet level, right? So let's click on Wireshark. And I'm sorry I removed the whole cool black screen. Unfortunately, I want it to be easily readable by you guys. So I'm sorry about that. I hope I haven't offended at least many of you. So in Wireshark, let's go ahead, select the interface. I'm selecting ETH0, and my Kali is running on VirtualBox with NAT enabled by default. You could probably have it in bridged mode as well if you like. I'm going with NAT at this point. So let me go ahead, start the sniffing. And right now, as one can imagine, there is pretty much no traffic. So I'm going to go in here and let me go ahead and basically try and fetch the home page of securitytube.net. So one of the easier ways to do that is to use a program called curl, exceptionally useful and been around for ages. I'll use the verbose mode so I can pretty much see what is happening. And I'm going to type in securitytube.net, hit an enter. If you notice, I get a huge output in here. Let me scroll all the way up. And if you notice, I typed in curl -v www.securitytube.net, and curl after that goes ahead, tries to make the connection. And what does it send as soon as it succeeds in connecting to port 80, which is the default port for HTTP service? It sends this specific string here, right? Get / HTTP 1.1 user agent blah 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 host securitytube.net except so on and so forth, right? Now to look at this in a structured way, what you would see next is we pretty much get a response from the server saying HTTP 1.1 200 OK. This is what we called HTTP response code. 200 is an example. 200 OK pretty much means what you requested for is available and here it is for you, right? And then after that, we have the whole HTML file which is being sent to us, which is present at the home page. Now let's shift back to Wireshark and really see what happened. Now the first thing we actually see is a set of ARP requests and responses, and this would happen depending on how your gateways etc. are configured. The next thing is DNS, of course, right? We go ahead and send a DNS query for www.securitytube.net. We get a response, and that's how we figure out the IP address. Now HTTP, even though it supports both TCP as well as UDP, pretty much I think 99.9 recurring websites only support or pretty much only use HTTP over TCP, right? There are cases where HTTP can be used with UDP as well, such as in the case of SSDP and all of that, but pretty much we won't bother about it because we are using whatever we are learning right now from a web application perspective, right? And in which case typically HTTP uses TCP in the underlying protocol. Now, if you notice, what is happening is the TCP, SYN, SYNAC, ACK, or the three-way handshake, as you can see, is going through. These are the first three packets. And after that, we see a packet which pretty much tells us that this is an HTTP GET request. Now, in the next video, I will get into what GET, POST, HEAD, and all of these things mean. But in a very simple explanation, for the time being, all of these are what are called request methods, right? So GET is the most common request method which is used, and this is really what we have initiated using curl. Now let me quickly look at the actual frame for the GET request. Now the first part, of course, is basically a small header which is prepended by Wireshark, which talks about when this frame was caught over the air, the size captured and stuff like that. The second is the Ethernet frame. Third part is the IP header. The fourth is the TCP header. And finally, above that, at the application layer, is the HTTP header. Let's go ahead and see what's there inside. And this pretty much mirrors what we saw here in our output. if you recall just moments back. So this is what we had seen, get slash HTTP 1.1 blah blah blah, and this is really what is going here as well, get slash, and this is nothing but pretty much gets the root document, or in most cases what we really call the home page. User agent, if you had used a browser, would have been Mozilla, Firefox, and a long string really, which talks about even the capabilities which the browser has to some extent. In this case, it basically says curl and the version of curl, because that's the user agent which curl internally uses. And then you have a host header, which pretty much tells the web server what is the host name we are interested in with respect to the home page we are requesting, right? So many a times you can have multi-homed hosts as well, in which the same host or web server can go ahead and service multiple domains. And after that, you have a bunch of other header fields which aren't very interesting from a security perspective. And you see tons of them as we start using regular browsers, right? So this is how a simple HTTP request looks like. And you pretty much have a lot of other packets belonging to the same request after that. Now, after the HTTP request goes through, the client goes ahead, sorry, the server gives back the response, and here is where the response is documented. If you see, it says 200 OK, and if I kind of go back in here and look at the response, this is what the server has sent back: content type, cache control, blah blah blah. The interesting header field here is server, which is Google front end, right? Interesting. That's because I'm running securitytube.net on Google App Engine, and I think they have their own customized servers. And after that, you finally have your line-based text data, which is nothing but the HTML page itself, right? Okay, awesome. Now let's go ahead and try and do this whole thing manually. And that is what we are going to see in the next video, where we quickly try and do this with Netcat and try and understand some small things about HTTP 1.1 versus HTTP 1.0. So that's all for this video, guys. Thank you.